We're going to take a look into one teacher's classroom, and we have that teacher with us today. Bethany, welcome.
Thank you.
So, Bethany, can you tell us a little bit about your teaching background?
Well, I teach high school science, and this is my 6th year as a science teacher. I teach a little bit of everything, biology, chemistry, AP biology, and sometimes 9th grade integrated science. And I work at a school that's pretty high needs. It's a lot of students who receive free and reduced lunch, almost 80%. And it's also a very diverse school. So it's a fun and challenging place to work.
So Bethany, we're taking a look at a unit that you taught on the gas laws. And you picked a really interesting phenomena to anchor this whole unit. It was a railroad tanker car that just mysteriously imploded after it was steam cleaned. But let's back up, and can you tell me a little bit about how you plan for a unit like this?
Okay, well, I know that the gas laws is a unit that a lot of times is taught, and I have taught it this way in the past too. Kind of a march through the different gas laws and some quick look at math and like the PV equals nRT, but not a lot of conceptual understanding that students get from those equations. And so I really wanted to think of a way to help students understand both the conceptual understanding of what's happening with gases as well as the mathematical equations related to that.
So you have told me in the past that you really like to unpack the topic and then recreate an explanation for yourself of some phenomena that you want to use in that unit. Can you tell us about that unpacking process?
Yeah, so I like to find some sort of puzzling phenomenon that I think encompasses the big ideas that I would like to focus on in the unit. And then I carefully try to write an explanation. I try to write an explanation for those big ideas and kind of taking each piece of it apart so that I know like each little piece that a student would have to understand in order to reach a full explanation.
And then how does that, creating that explanation for you, help you line up activities that you want to engage students in?
Well, I actually make a chart of those, each piece of those ideas, and for each piece I try to look for an activity or an experiment or a reading that students could complete to help them build understanding of each of those pieces. So it helps me actually guide my whole lesson or my whole unit plan by lessons to build that understanding.
So Bethany, we're going to show a little video in a moment here about the first day in this unit. So what did you try to do in the first part of this unit?
Well, as you'll see, I showed the students a video of the tank car imploding, and I like to give students some sort of visual to see or like to observe, so something to observe at the beginning of the unit so that it really gets them thinking and questioning about what's happening. And then I ask them to tell me their initial ideas about why that was happening. And so I like them to draw a model of what they think is happening, and that really helps me get to see their ideas. A lot of times if they just have to write about it or talk about it, it's harder to see what they think is the cause and effect. And so I like them to show me a lot of times what's happening at the beginning, the middle, and the end of a story or a phenomenon, so I can see what they think the processes are that are involved, the differences that are happening throughout the story, and really show some of those cause and effect relationships.
So Bethany, we're going to now look at the video of the first day, and what I'm asking our audience to do, our teacher audience, is to listen for your kids' partial understandings. As you remember, you'll hear a lot of partial understandings that they have. And also, I want them to watch how you and the students use their drawn models as a reference point to start explaining their thinking, not just to you, but to each other.
Okay. Okay, so we're going to continue thinking about how gases behave, and we're going to start by looking at a scenario and trying to explain what's happening. Because for the next 2 weeks we're really going to focus, we've started by looking at the different phases of matter, but we're going to focus in on how gases behave. So our purpose is to investigate how gases behave and what factors affect their behavior. And so we're going to look at a scenario of this tank car. So, let me get the light. You have this tank train, and the interior of the tank was washed out and cleaned with steam, and all the outlet valves were shut, and the tank car was sealed. All the workers went home for the evening, and when they returned, this is what they found. Does anybody know what they found? Maybe it exploded?
Oh, it exploded. Oh.
Does anybody else have an idea of maybe what they found when they came back? So we have.
You can see where the, or if it has anything, because it froze.
Okay, so maybe we had a phase change, maybe some stuff froze inside of it. So we have the idea of maybe it exploded, maybe it compressed, and maybe we see, what? Did you say steam? Maybe you saw some steam coming off of it? So it was washed with steam. Okay, so let's see what happened. Here's what they found when they came back.
Holy. Why'd that happen?
Good question. That's what we're going to try to figure out. So I have a video of it actually happening too.
Before I ever stopped learning. That's
I
crazy.
just kind of just went.
Okay, so here it is.
See that?
That's crazy. Is it because there's nothing inside of it? It's molded together?
Just sit here and lost weight.
Okay, so pretty crazy event here. Okay, so what I'd like you to do is get with your groups, share your ideas with each other, then try to come up with, as a group, on an agreement for now what you think is happening. Remember, we're going to spend the next 2 weeks learning about what's happening. So now this is just your initial ideas, some guesses based on what you already know about gases.
Basically, I was just like, I don't know, like, because when the molecules are inside the tanker with the steam, okay, it's going fast.
Yes.
And outside it's just regular, and then
But what if it freezes, and what if that makes it,
yeah,
you know,
maybe it was the
squeeze down?
cold or something.
Like it made the steam freeze or something.
Yeah, maybe it was the cold. Because remember when the thermometer blew up?
He wasn't here.
Oh, there's a thermometer here.
Yeah, that's fine.
Yeah, it exploded, right? Right. That was because it was too hot. So
That was too hot.
You're talking about when it freezes.
then it went reverse, imploded instead of exploded.
It was compressed.
Yeah, but see, it didn't explode.
It imploded. It's opposite. Because that's why it was so fast.
I don't know how to explain it. Okay, so you know how when people have like a water bottle and when they suck on it or whatever, and like all that air comes out of it, it just compresses down immediately. I think that's kind of like what happened with the thing.
I don't get how it suck up a whole big thing. That was a big.
It is big, but the problem is it was sealed, so there's no way that the air could have been sucked out of it.
So I'm saying, like, there's no way nothing can be in it. That's what I'm saying. Like, I
Well,
don't
nothing's
think,
in it, but
yeah,
the
nothing's
steam,
in it.
I think, in the air maybe.
Busting, yeah.
So, I don't know. It was like a tornado effect, hot air, cold air, mixing.
So let's write our ideas down.
Okay, so let's start with the beginning here. What's happening?
In the beginning, the steam expanded and the high pressure was pushed.
Okay, so what is this high pressure? Where is the high pressure?
Like, you know how the project we did, like when you put in a hot water and that balloon kind of blew up from all the steam?
Okay, so can you show me that in this picture? Where is the pressure? What's the pressure doing?
It's pushing. It's like pushing. Wait, it was pushing. See it?
Okay, so let's illustrate that. So it's pushing, and how is it pushing it? Like, what's going on with those?
Expanding.
It's expanding.
It's getting hot.
Okay.
It's trying to escape.
Okay. So you might want to add that to your right. Okay, so we have pressure against the container wall here because why?
And you have lines, Carson.
Because it's hot.
Okay, and so then what happens? Oh, so it's taking up more space because it's expanding. Okay, and then what do you see? What's happening in the middle here?
It's starting to go back to water.
Okay.
Doesn't take up as much space.
Yeah.
Okay.
It's down.
Okay, so you have some liquid here, and so maybe, so you know how this has, you show me the pressure here, maybe you can try to show it here. And what are these arrows?
The pressure is making it contract.
What pressure? Pressure of what?
Of the steam.
The temperature.
Okay.
It has to contract.
So it's putting less pressure against the the walls of the container. But how does that make the container then end up like this? How does it crush?
Because it's the pressure on the outside of the container. It's stronger on the inside now.
Oh, okay, interesting idea. So there's pressure in the air, and somehow that is now less than this? Oh, more than this? Yeah, right. Okay, so maybe you can figure out a way to show that in this picture then?
It said that it was just like regular air in the beginning.
Okay.
This is air on the outside, that's the air on the inside.
Okay.
And then when they steamed, it was like moving like crazy,
Okay.
the molecules. And then, what did we say? It was complicated.
Because this looks empty now. Is it empty?
Well, I mean, maybe it has regular air in it.
Because this is before they steam cleaned it, and so then they closed all the valves,
Oh, so
so nothing can get in or out. So there still has to be something in here. What would be in here?
just some air, regular air.
What happened to the steam?
It went out when it exploded.
It didn't explode.
I mean, imploded because it, broke. So now there's holes all over it. So the steam went out.
So let's assume that it didn't break, that it just crushed. So like
And the
starts-
steam is still there.
So the steam is still there. So how can you explain what happened? Maybe the steam is still there. Why would it turn into liquid?
I forgot what I
Just went
said.
back to phase.
Okay.
You said something, right?
Yes, and
So it went back to liquid. So how can you show that in your picture?
one could just draw some water.
Okay, go ahead. And then I want you to think about what's going on here, and then if it turns to liquid, why would it cause this crushing? Why would it crush in?
Because we learned with the heat that it expands. So if it's cold, I don't know why I think it's cold.
I guess maybe it's just a
Well,
reverse.
it was overnight, right?
It would not expand.
But it can't come out. It can't come out. It's sealed.
It probably went reverse. Instead of just like coming into like first liquid then gas, I guess it just reversed.
Okay, so you need to think about what would cause this to implode.
So if it was for some reason the molecules were getting smaller, they don't change size.
The gravity. Draw the gravity pushing down the.
Just draw a big arrow. So we know when things get hot.
Put gravity. Next to the gravity.
And then draw it inside, like arrows pointing in every direction. No, like out, like arrows going the other way.
Like outside? Or
Like bumping out of, on the walls, yeah.
So what do you think? Something with steam. Okay, so let's think about steam here. Okay, steam is a gas strip, and so they steam cleaned it, and where did that steam?
Use the pink one
So
to
if you
show
draw
the
the
arrows.
molecules of steam in here, how would you draw that? Okay. Little circles, and what do you know about like how?
there's no more space for the molecules to go.
So
So like, they expand all over the tank, and that's what made the explosion. But what pushed the tank down is, I think, it's gravity.
Sealed container here, so can it escape? Okay. And so then what happened?
Like maybe the steam inside the tank made the metal,
The next day. So what do you think could have happened overnight that might have
Yeah.
and then it made it more easier for,
Explode.
yeah.
Put down.
So what do you think it might do? When you get it, when it gets cold, what do you think?
And gravity was strong.
Yeah. Put gravity.
So if you have some steam, some water vapor, gas, and then
Well, this is the tank, and like the molecules inside of it are like moving around like quickly. Or like over here, it shows that the temperature on the outside of it kind of affects the temperature inside of it, but we don't really know what the temperature is. And like as it's cold, the air wants to get inside the tank, so it's like pushing on the tank, and like the molecules inside of it start moving slower, and then over here, the molecules stopped and everything dropped because, like, as it's cold, the steam inside of it turns to liquid and then it compresses, so it drops down. And then, yeah, whatever you said, whatever.
And then in the middle, the steam pulled down, the pressure contracted and decreased in size. And at the end, the gas returned to liquid, and the pressure inside became less pressure outside.
It became what?
Less pressure outside.
Less.
I mean, pressure than the outside.
Okay, so there's less pressure than the outside, so why would that make it crush?
Because there's more pressure outside, so it pushed in the tank.
It's a gas. It's moving very fast, trying to escape. It doesn't like to be contained. But because it's left there overnight, the temperatures outside change, making everything on the inside of this, including the steam, change in temperature. And it probably cooled the steam down, making it become a liquid, water, something, whatever. And once it became a liquid, it wasn't really trying to get out of the tank anymore, so there was less pressure, and it was still kind of probably cold outside when it happened. So we think that, of course, air was trying to get into the tank, and we drew like this giant air foot trying to step on the tank, making it compress.
Okay, and talk about, can you just tell the class, so if we have they're saying there's this imaginary foot that's air, why would the bottom, if you try to step on the top one versus the bottom one, why did the air foot crush the bottom one?
Well, if you try to step on the top one versus the bottom one, the top one has like more pressure of it trying to explode than it would to collapse inside. So if you were to step on the bottom one, you'd probably blow up. But if you were to step on the bottom one, there's less pressure, it's easy to step on and collapse.